Okay, so everyone should have a post-it note of 3 or 4 different things, which I'll get into in a second. Some of them is some situations, some of them is a quote. For you, Lindsay, I put 3 things in the chat there as well. But everyone should have a couple of different things on post-it notes there, which you're going to be using in a couple minutes. You're going to need to stand up for it, just so you know. Not yet, but when I want to start, what we're doing in now is moving on to our 4th unit, which is probability and odds. So like, this is the probability that something will happen, right? If I was to take a coin, I was to flip that and catch it, what's the odds that this is heads? 50-50, right? It is heads, actually. So like you guys have been studying this all your life without knowing it. So I'm pretty sure you'll pick it up fairly quickly. But one thing I want us to do, drag that over. So like I said, small text. So if you struggle reading, you'll either have to really use your ears or you'll have to join the Zoom in here. But so what I've put on here is I have put a bar. Now this is something that we call, we're gonna be using as a spectrum.
Did you make it really small on purpose?
I had to fix stuff. Yes, I did. So if I was to say, hey, what's the odds of, flipping a coin and from heads? 50%. Oh, I put 50% right here. If you had something that was odds of like a 0% happening, like what's the odds that I'm going to be on the moon in 2 hours from now? 0, right? 0% chance there, right? And then like 100% chance. What's the odds that it's going to snow sometime in winter next year? 100%, absolutely 100%. So this is the spectrum, right? We have stuff from really rare, very unlikely to happen. It moves into the realm of about 50-50, more likely, until it's like completely certain. So what everyone has is everyone has a phrase. First of all, everyone has phrases and everyone has situations. I want you to look at the situations, not the quotes. For example, you have stuff involving cards, dice, like winning the lottery, stuff like that. I want you to take a sticky note and I want you to put it where you think it is. So for example, someone here has you flip a coin and it ends up on like heads. Someone here has one of those. If you had that, you'd be like, oh, 50-50 chance. You put it right there. So you're gonna be actually sticking it to the screen.
Oh, just like
Not on your computer, but on here. On here.
on it?
On here, yeah. And then I'll move these to where they're supposed to go, just so Lindsay can see as well.
Like
You will do it right here, exactly where I'm stepping. Yeah, like, you'll actually walk up here. So if you have the 50-50 one, right there. So I will give you 2 minutes to give those, to give it a thought on what you think the odds are. It doesn't need to be exact, doesn't need to be perfect. We're just kind of exploring the topic right now. So anywhere on this platform.
Okay.
Yeah.
Like say if you think 30%.
If you think 30%, like somewhere right here, you don't need to go to the, if it's less than half as likely, somewhere around here. Yeah. Sorry. What is what?
0%.
Sorry, what was that?
I got 1.
Oh, that's a quote. Ignore the quotes for that. Ignore the quotes.
So 1 is 15% or 70%?
Well, so just whatever you guys have, I want you to put that up there. For you, Lindsay, you could just like type in the chat where you think stuff would go, and I will. Yes, actually, before you go, Jasmine, before you go, let me just. Okay, no, you're good now. You're good now. Yeah, so I want everyone to put their sticky notes up on the board there, not the quotes. Ignore the quotes. Okay, and then let me.
The kind of like pocket blood vessels. Yeah.
You might have to, just do your best for it as well, by the way. Does not need to be perfect.
Can we use, like the quote ones too?
Not the quote ones yet. So I need someone as a volunteer to please read out where everything is up there so I can start pulling it over there. I'm sorry, so I know that Lindsay said probability of an even dice roll was, she said 50-50. Dice roll even, so I'm just gonna move that right there. Okay. So,
We're supposed to be all
sorry?
like the quotes.
Oh, the quotes one, yeah, keep the quotes ones for now. Yeah, sorry. Well, you know what? They're already up there. You can leave them up there. I just wanted to do one thing at a time here. So let me just reposition what you guys have up there to what's up here. So yeah, flipping a coins with tails. Yeah, that's about a 50-50, right? I shortened it up from what you guys had just so I could fit it on here. But yeah, flipping a coin, you have a 50-50 shot, right? 50-50 shot of flipping a coin and you getting heads or tails. Drawn a red card from a deck of cards. Yeah, 50-50, right? What else do we got here? Oops, I cannot do that. Let me just take a look. There's 4 things there. 4 things here. So we have the deer thing on the very left hand. So you guys said like something like, you know, right here. Actually, like honestly, that's not bad, like bad odds because I see a deer every time. There's so many deer on the highway because they eat. There's like a grain silo where I drive beside, so they're always eating there. At least one day of snow in February, people put that at basically 100%. Sorry, bear with me 1 second. Pulling anything but an ace. Rolling a 2, rolling a dice and landing anything but a 2. Anything but a 2. Pulling anything but an ace. And then there's a couple that are missing. Win the lottery, roll a 2, rolling a 2. Does anyone have this pulling an ace from a deck of cards one?
I do.
Oh, you do? Well, you don't need to come up, but where would you think that would go around here? Tell me when to stop.
I would
So
say.
that's your friends.
Yeah, I'll just put it right here just for the sake of space, like something like this. Oops. Something like that. Oops. Cool. So what you guys have done is and we have thunderstorm in summer. Sure, that would be really high percent. Cool. So we have a pretty good grasp on probability already, right? And it doesn't need to just apply to like math stuff, right? That's just real life stuff. Yeah, it's probably going to freaking snow in February, right? It's just, that's a Canadian winter, right? It's probably going to thunderstorm in summer. There's a small chance I'm going to smoke a deer on my way home tonight, right? Yeah. So that's what I wanted to get to next. So you guys now have quotes. You should each have 1 to 2 quotes that you want to place as well. And so we use this in our everyday language. Like if I was to say, like, I don't know, hey, are we gonna, I don't know, if someone asked me like, hey, are we gonna have a test on Thursday? And I said, maybe, you know, that's somewhere around here, right? That's somewhere in the middle. If I said, yeah, we're probably gonna have a test.
But your maybes are more like.
Well, if I said, hey, we're probably gonna have a next test like Thursday, you would probably put it like closer to 100% than 0%, right? You'd put it on this right half because I said, yeah, it's probably gonna happen. So we use this type of language every day for different types of situations. Now, what I want you to do is I want you to just try to imagine a situation with your quotes and place that where you think it could be. If you're not able to think of a situation, think about the Super Bowl. That just happened. What are the odds that the Eagles are going to win? You know, if you said a fat chance in hell, probably close to 0. You don't think that's going to happen.
The quotes.
Yeah. So now you want to go up there and place the quotes. Yeah.
Like, the guarantee.
Yeah. You can put that up there. Yeah.
What it is.
Oh, it is up there. Oh, I see.
I didn't realize.
No, that's fine. That's fine.
With the quotes?
Yeah, so now you want to put the quotes up there, yeah. Yeah, it doesn't need to be exact. Perfect. Okay, so cool. So everyone has some stuff up here. So let's just take a look at what we have. So there's a small chance close to zero, right? There's not a big chance that it's closer to zero, right? It's very unlikely to happen. I doubt it. Same thing. Close to zero, right? Yeah, I doubt that's going to happen. I doubt I'm going to hit deer on the way home tonight. Fat chance in hell. So this one would probably be closer towards the left side, but yeah, about like you could say 50-50. It should happen again. About 50 might happen, 50-50. 70% chance of rain today. Well, that just goes to 70%. I'm pretty positive that the Riders are going to win the Grey Cup, right? More than 50%. And then it's guaranteed, yeah, about 100%. So good work with that. I have recorded this with my phone. I'm just going to pull those off now. Yeah, so we have a really good understanding of what probability is. Like I said, you guys have been doing it whole life. We don't need to. Oh, yeah.
I don't know. You ever try to flip a coin and it lands right on its side, like legit right on?
I've not had that happen to me yet, thankfully. I usually do the coin example a whole lot. But I haven't had that happen to me yet. Okay, so what we're dealing with today is, let me go to that. So we're dealing with probability and odds, right? So we know probability is the chance that something's going to happen. I flip a coin, probability there is 50-50, right? I have a 1 in 2 chance it's going to land on heads. I have a 1 in 2 chance it's going to land on tails. There's experimental. So what we're focusing today on is something called experimental probability. Now, how the heck is this different than probability itself? Well, we're going to.
You do the same experiment over and over and over again.
Ooh, so you're really, really close. So I like what you did. You clued in on the key word. The key word there is experiment. You could, that's partly what it is actually. It's based on a data set. It's based on an experiment. Something happened. We did something. We're looking at the data. So what we're going to do, I'm going to hand something out. Now, Lindsay, I apologize. I'm handing out Smarties right now, and I can't really send them to you electronically. So you're going to have to bear with us on this one. First off, if you look at the chance to eat them, please avoid eating them for now. You can't open them. That's fine. Please don't sneak one right now. You'll get to eat them in a couple minutes. It will not take long. So don't eat the Smarties. So what I want you guys to do is I want you to, because I want you to open them and I want you to organize them. We're going to be using the Smarties for something.
How much I eat?
Don't eat them.
You want some of the beets?
Tell you what, once you sort them, once I write down everyone's results, it'll take a couple minutes, then you can eat them. So like 3 or 4 minutes, something like that. And Lindsay, I do apologize. I can't send Smarties over the internet. It just is not a thing. And I'm not crazy, right? There's 8 colors. If not, we'll have to.
I think they're round of finger.
Those green ones aren't very green. Brown, purple.
I ate one brown by accident.
Don't give them.
Blue, purple, yellow, and
I just want these colors.
That's what it is. Green. Colors, green, yellow. Hey, wait, no, we pink, red, orange,
Seven ones.
yellow. There is green,
What am I missing?
there's purple, there's brown, there's blue,
Yeah, that's it, what though?
Oh, yeah, there's something blue.
Okay, so that's really, okay. Yeah, there's 58 colors, there in the box. Well, sorry, there are 8 colors of Smarties that exist, and they don't need your box. Again, don't eat them yet. You can eat them in a couple minutes. It will not be long, I promise. Hmm? Okay, so we now have a total sample size from our Smarties. So what we just did, again, we just did an experimental probability. Our experiment was we figured out how many Smarties were in a box. Now, something that's quite interesting though is we all have pretty close to the same amount of Smarties though, right? We all have very close to the same amount of Smarties here. But our distribution, the stuff on the bottom, completely way off, especially with the blues.
You mean I got less?
Yeah, you got less apparently. You got the least amount. So we just did an experiment, and now using this, we can figure out experimental probability. So let's say, for example, I wanted to know. So again, if flipping a coin is 1/2, it's a half chance, right? What do you think our odds are of just getting? Let's go with what was our odds of getting a blue Smartie in general?
4.
Yeah, there's only 4 blue Smarties out of a total of 221 Smarties, right? That's how many there are. So if you did 4 divided by 221,
0.018%.
it is a. So you'd have to times that by 100 to turn to a percentage, but yeah, so it's a 1.81% chance, something like that, right? So the way we would say this is, instead of having to type like, yeah, about 2%, right? Yeah, it doesn't need to get too complicated. But yeah, so our probability of a blue Smartie, because this is how we write it. I'll get into this in a bit, but probability of a blue Smartie is 4/221, right? There is a total of 4 blue Smarties, and there's 221 total Smarties. Cool. So we can look at this, we can analyze, we can make a probability based off of this. Now, next question, of course, though, is could we use this to reliably calculate Smarties next time? No? How come? If I was to give everyone another box of Smarties, do you think you'd get the exact, so Kim, do you think you'd get the exact same distribution? You'd get 42 Smarties, you'd get 0 blues, 2 oranges?
Maybe there's more blues next time.
Maybe there's more blues, maybe there's more Smarties, maybe there's less Smarties. Who knows? But so we can use this, like we have a pretty good sample size here once we added all 5 together. Other than this blue one, they're all like fairly close. They're in the 20s to 30s, something like that. The brown ones are a little bit low as well. But for the most part, it's either 27, 33, or 37, with the exception of our 2 little outliers here. So I have a couple questions for you. I want you to think of. You are going to need to write these ones down. A couple questions for you. I want you to think of.
That probability for how many people got like Smarties?
Well, no, because we use our entire sample size up there. Yeah.
What is 4 of us?
No, there's 5. Jasmine just went to the bathroom, I think. Yeah. Oops. Sorry, I realized my questions never saved, so I'm quickly retyping them. Okay, so I have two questions for you. Which are these ones? You can either write them down or you can remember them. Because I need to go back to that table in a second. But so question one, you're gonna, first off, I do have another bag of Smarties, so that's what we're doing. But what's your odds of getting a brown Smartie in that? So you're gonna use the information we have to make a prediction. So first off, what's your odds of getting a brown Smartie? And then you want to figure out how many pink Smarties you think you're gonna get as well. So brown Smarties and pink Smarties, based on this information here. So before you open this next box, I want you to quickly, you can write down your pen, write down on paper, write it somewhere before you open the box. Right? Odds of getting a brown Smartie, odds of getting a pink Smartie. This is kind of what backstory is mean as well. But and if you still have Smarties, please just separate them too. Kind of. Yeah, brown and pink, yeah. So if you guys still have Smarties on your table, all I ask is that you just make sure that that's put to the side so it doesn't interfere with that Smarties, right? Because you don't want to have a box and a half of Smarties and pretend that that's a regular box. Don't do that. So I left it open very intentionally there. So I want to start talking about that. So the first question we had was we wanted to figure out what's the odds that in your box you would get a brown Smartie. So what's a couple numbers that we got here? Just throw them out there.
There were 90 something or 108. And but it was. But
Okay, so you're thinking maybe like 10%, and I'm guessing you got that by taking the amount of brown here to, yeah, so 221 over 221, okay. You also said 1 and 8. Okay, I can see how you got that. Well, there's 8 different colors, right? Is there any other numbers that we got there? Did everyone get a brown this time?
Yeah.
You got 5 of them? Yeah. So no one else had any other numbers there? 10%, 1 over 8?
I got like 9.5.
Yeah, so but close enough to.
Yeah. I got 8.
Well, what about 100%? This is a question left intentionally like open-ended, but like we've all gotten brown Smarties now out of 2 boxes of Smarties, right? So isn't there 100% chance that we're gonna get at least one of them?
and if you look inside.
If you look inside. So again,
What any chance of 100% for sure you can get it now?
well, right now, isn't it 100%? We've gotten brown each time, so there's 100% chance that, or like a 99 point some percent chance that we're gonna get a brown in there. Maybe we only get 1. Maybe instead of like 9 that Kim got in her first box, maybe we only get 1 like Austin did. But everyone here got a brown Smartie, not once but twice. So about 100% chance. Again, none of these are like really correct. I understand how everyone got to this. We're going to learn how to calculate this a little bit later. So what we did was we had an experiment. This is experimental probability, and then we're using it to make a theory on what the next box would be, theoretical probability. And then for the number of pink, what was our answers there? How many pinks did you calculate you would get in your box before you opened it? You got 6? How'd you get 6? Oh, but before you opened it. It's not so many you actually got.
At least 5.
Oh, at least 5? Okay. Okay, anyone else got any numbers?
At least 5, like 5.4% chance.
So 5 plus. Okay. So you took the mean, that's where you got 5.4?
Yeah.
Okay, yeah, so that makes sense. You took the mean, so you got 5.4 and you just like rounded it to a whole number. That seems like a good theory. What did everyone get for pinks out of curiosity?
I got a 12.21%.
So you got 12.2.
Yeah, I just.
Oh, so 12, you said so 12.2% of your box?
Yeah.
Okay. So some of you went like, I'm gonna have this, like this many pinks. Some of you went, I'm gonna have it as this like percentage. Okay. Did anyone get less than 5? Like when you actually counted it out, did anyone get less than 5 this time? You got 4? 3? Okay, 3, 4s. Austin got 6, I think. You got 2? Okay, so it's really all over the place here. That makes it a little bit harder to kind of draw a conclusion, but either way, none of these answers are incorrect. It's like, it makes sense how we've gotten these numbers, right? So like the whole point of this is it's really easy to interpret something. So the wording of a question is really important. The wordings of these questions were very broad. They were not very specific. It did not specifically ask for it in a certain way. Like, tell me the amount, tell me the exact number of pink Smarties. I can understand how someone got a percentage out of that. What about for these brown ones? What's the odds of getting a brown Smartie? Like pulling one out of a box, just getting it in a box in general. Like it's very hard to interpret, right? So the wording of something plays a factor, but you guys kind of calculated out all the possible possibilities that I could see there. So that's really good. So I want to start going into this here, which would be kind of helpful if I were to pass those out. I'm just going to hand these out here. I'm going to come back to this in a second. Oh yeah, you can get out of the smart stuff, or you can put it in the box. Okay. So there's a couple of formalities we need to do with probability. So there's a couple of formalities. So I want you to do is I want you to grab that probability booklet here. Where's mine? Where's mine? There's mine. Okay. Okay. So I want you to get your probability booklet. We're going to be using that in just a second. So there's a certain notation we need. That's the fancy way of saying a way to write stuff that we use for this. Because remember, very first thing we learned was that mathematicians back in the day were starts with an L, ends in a Y, lazy, super lazy. So if you're asked this question, if you're making a statement, what's the probability that coin toss will land on heads? First off, we know what the odds are. What's the odds? 50-50 specifically. You could list that as, you can list that as 1/2. You can list that as 50. Oh my gosh, 50%. I'm just going to type it out. Bear with me.
It looks like you're writing on a heartbeat there.
Yeah, kind of. I don't know why it does that. I'm just going to type it out. So first off, you guys already got an answer. You said, hey, it's 1/2, or it's a 50% chance.
Are we ready?
Nope, you're not writing this down. You're not writing this down. Or a 0. Thank you for the question. Or a 0.5, right? These are the possibilities that it could be. Or you could also say, 1 and 2. There's a bunch of different ways. You could say half. This all means the same thing, doesn't it? Those 5 things there mean the exact same thing. Now, instead of having to write the probability that a coin will land on heads is those things, what we do instead, again, because we're lazy, is we're just going to say, hey, probability, P. The probability that it's going to land on heads is equal to this. So again, so what we could do is I'm just going to put the 1/2 just because that's the first one I have there. Isn't that shorter, right? That's a lot faster to be able to write. If you read that, you should be able to understand it. The probability of heads is 50%, 1/2, half. There's a half chance that it's going to land on heads. So this is the notation that we use whenever we deal with this. So that when we see that, that's what we're going to be, whenever you see that P thing, that's what that means. So let's kind of jump straight into this here. I'm not going to spend too long on it, but everything here is going to involve fractions, decimals, percentages. Luckily, we've worked with percentages for a long time, and our calculator can simplify stuff for us. So perfect. So I'm just going to ignore this. We're going to jump straight to page 145. And I want you there's this little table here. I'm going to zoom in a little bit. I want you to add another category. I want you to extend that table a little bit. There's one more we're going to add. So I'm just extending this table. and we're going to use words. So now we have fractions, decimals, percentages, and words, right? What's the probability that when I flip this coin, it's going to land on heads? About half. That's a word. It's 1 in 2. That's a word. So again, your calculator can do most of this for you, but just to give you an idea, all these things means the same. These mean the exact same thing, right? A fraction, the odds of, I don't know, maybe they have some 5-sided dice. They said that, hey, the odds of getting this thing is 1 in 5. That's the same thing as 0.2, right? Your calculator can spit that out for you. That's the same thing as 1/5. That's 20%. We've learned how to do that. For words, that would be something like, there's a couple ways to do it, but 1 in 5. All of these 4 things mean the exact same thing.
Like 7/10. 70%.
Yeah, so 7/10, 70%. Ooh, I see what you did. You did, even though it's like 70%, you still went 7. Or 7/10, that works too. Again, there's different ways of wording it, but the whole point is we read a situation, we should be able to understand what it's actually telling us. So sure, I'm gonna, instead of 7 in 10, sure, why not 7/10? 7 of 10 times you can expect this thing to happen. Now, of course, what you did here, Stephen, was you simplified it, right? You didn't go 70 of 100, you went 7 of 10. You simplified it to the. So, well, 7 of 10 times, so it'd be 7/10. So it'd be 70%, 0.7. Like these all mean the same thing. Now, for this one here, for this percentage, now we know that percentage, that's 12/100, right? But if you put that in your calculator, it's going to simplify it to be like 3/25. So you want to always break it down into the simplest terms. Most of the time want to break it down to the simplest terms. So this is a decimal, though, would still be 0.12. How would you write this in words? This 12%. How would you put that in words? Well, you could do 12 of 100, but we want to simplify it, right? So technically it'd be a 3/25. But Kim, you could put 12 of 100, and again, we can understand what that means. We're not going to get anal about this. We're just going to be like, yep, this is what it is. We have an understanding of this. This is stuff we've worked on. I'm going to scroll past that in like 10 seconds. That's not new stuff to us. It's just a quick review of it because we need to have an understanding of this to be able to properly read questions. Your calculator can do the simplifying work for you, but you still have to be able to read the question and understand what each of those mean. So let me just kind of scrolling down here. Again, we've already done, you can do this if you want. We've already done that, so that's good. Boom. 3/25, yeah. Okay. So now on the bottom of page 146, you can see these definitions. This is stuff we've already done. We know what a probability is. It's the chance of something happening. And we can put that as a percentage, a fraction, a decimal, or in words, right? So we know what a probability is. And we just did experimental probability. We ran an experiment with Smarties. If you ever want to jog your memory, just put Smarties down here. You ran an experiment. The experiment part is the key word here, right? And you'll see why tomorrow. But with experimental probability, we look at an experiment that we did, and we compare the total number of a certain event, amount of pink Smarties, to amount of total Smarties we had. So experimental probability, we do a calculation. Now they use fancy words here, right? The occurrences of A. You could put whatever you want in A. We're going to put pink Smarties. The occurrences of pink Smarties in a data set. We have our data set, and we ran a trial to figure out how many times we get pink Smarties. We ran a set to figure that out, right? And so then, when we did that, we can use those results to make predictions about the chance of future occurrences, right? We guessed how many we'd get in the next box. So that's experimental probability. Now, what you're going to want to do is you see this little thing here on boxing. You're going to want to box that, circle it, star it. This is what we've been doing the whole time, just without doing it. This is the math notation, the way they want it written. The probability of this thing happening is equal to the total amount that it did happen versus the amount of possible outcomes, right? If I want to figure out the probability of, again, flipping a coin and it going to heads, if I flip it, first off, how many possible outcomes on there? There's two sides of a coin, right? I can either get heads or I can get tails. There's only two outcomes. Yeah, and there's a 1/2 chance. There's only one of those two, only one of them is going to be heads, right? If you roll a dice, probability of rolling a 6 on a dice, for example, how many sides are on a dice? 6. Yeah, and there's only one of those sides has a 6. What if I wanted to know the probability of rolling an even number on a dice? Rolling an even number on a dice. I know that's hard to read. So there's 3 odds and there's a total of 6 of them, right? So 3/6. You could simplify that to 1/2 as well, but both work, right? We understand what that means. Cool. So we know what probability is now. We know what experimental probability is, and we know how to calculate it in a way that the math nerds will understand how to read. Cool. And we know that we can do it as a fraction, a decimal, a percentage, or words, just like what we did above. So I'm just gonna zoom on down here to page 148. So zooming on down to page 148. So this is the same type of stuff we just did, except this time instead of counting Smarties, it's an on paper exercise, but it's the exact same principle. So they have a grocery store that sells toothpaste. They sold 75 tubes of brand A. Maybe that's Colgate. 23 brands of brand B, maybe Sensodyne. 57 tubes of brand C. I can't think of a third toothpaste. I don't know, no name toothpaste, sure. So 3 different toothpaste, right? So what's the probability of a customer buying brand A? First off, instead of having to write, don't write this down. Instead of writing this, we shorten that, right? Probability P of brand A is equal to something, right? Way easier. You can write that down now. That's okay to write down. Let me make that bigger. A little too big.
So they just have to add those numbers all together, right?
So that's one of the steps. Yeah, yeah. Because remember, we want to express this. I'm just going to scroll up for a second. Everything probability gets expressed like what's in that box, right? The number of outcomes we want, the number of people who bought brand A, and the total amount of possible outcomes, the total amount of toothpaste that were bought. So I always start with my bottom. What's the amount of total toothpaste? Well, I know that there was 75, 23, and 57. You add all those together, yeah, 155. That's my total outcomes, right? Ooh, I see what you're saying. So I want to get to that actually. Let me just erase that. That's a good question, Kim. So first off, you're right. There's 75 tubes of brand A because that's what we wanted to find, right? Now your question is, do I need to simplify it here? They want you to in this case. They won't always say. They won't always say, but they want you to simplify. Now, the nice part here is maybe, maybe you're not too great with simplifying it mentally. That's okay. Just punch in your calculator. It'll tell you. 15/31. Yeah. Cool. I'm gonna circle that. That's my answer.
Um. 40%.
Yeah, if it would turn it into a percentage, that's what it would be. They only want it as a simplified fraction, but you're right. That's still like correct, right? It's that much percent. They just want it written that way.
This is not a decimal.
Nope. They said they want it written as a simplified fraction. That's a simplified fraction there. So we're done.
This is a decimal.
Well, 15/31, right?
I don't know, but
If it was 30, yeah, it'd be nice and easy, but it's not.
Are you simplifying? I wasn't watching the wedding.
Oh yeah, so this is it. Like it's just 15/31. Boom, that's the answer. Because remember, the wording's really important, right? They want you to write that as a simplified fraction, which is what we have right there. So we've already have it in a fraction and it's in the most simplified form. So next question here is, so this is all based on still the same information we have up top. If the store sells 500 tubes of toothpaste, they want to know how many brand B they can sell. So this is where I want to take a step back to our Smarty thing, and I want to go back to Aiden's information that he gave. I'm just going to go off this for 1 second. So when we try to figure out the amount of pink Smarties we should receive in our second box, Aiden said 12.2%. And you got that by taking the 27 over the 221, right? That's the exact same way we can do this. Keep. So first off, how can we figure this out? Here's what we know. So how many tubes of brand B can we expect to sell? Well, how many tubes of brand B did they sell? What was their odds of selling a brand B? Over 155, because that's the odds you have, right? That's the odds you have. With those pink Smarties, I had a 27 over 221 chance. So I had 23 over 155 chance of selling brand B. But now I just want to know what if I sell 500 tubes? So of 500 tubes, I know that I'm this likely to sell a brand B, right? If I was to flip a coin 500 times, that's what I'm putting on the bottom here. Don't write this down. If I was to flip a coin 500 times, and how many times would it land on heads? You just take a half, times it by 500, right? So the same is true up above. It's just a lot bigger numbers. So 23 over 155. I'm just going to make sure my answer matches up with yours there, Kim. Ooh. So I like where you're going here. So the technical answer here is
You do fraction?
uh
Or but also how many tubes? So 74, right?
so 74. It's technically 70.
Can you sell 74.19 tubes?
That's exactly right. You cannot. So you're going to round that. So that's technically just 74. You can expect to sell 74 tubes of brand B toothpaste. So that's right. You cannot have a decimal if you're dealing with, like, this is a whole number, right? I can't sell half of a thing of toothpaste. You just don't go to a grocery store and it's like, oh, it's half off because it's half a toothpaste. So again, we have to read it carefully. We have to understand what it's saying, right? It didn't say round to the nearest whole number. We had to use logic to figure that out. That's exactly right, Kim. So I'm gonna scroll down in 5 seconds. So same type of question, just different numbers. Question 4. Give this one a shot on your own. I'm gonna give you 1 minute to try and get these as close as possible. Or try not, gosh, I just do as many of those as possible. So 1 minute to to answer question 4 as best you can. I didn't intend to take it out. It's about 30 more seconds.
For O blood type, do we add the positive and the negative together?
Oh, good question. Yes. Okay. So just jumping in straight into it here. So for question A1, it wanted us to figure out B plus. First off, what does this all add up to? 850, yeah, that's what I got too. 850, then how many people were B plus? B positive, sorry. 77. Right there's my probability, right? Isn't it 77 over 850 chance? You could put that as a decimal. You could simplify that if you could, but you could put 9% too, sure. I think that's what it would be. 77 divided by 850. Yeah, that'd be about 9.05, 9.1, 9. Either of those is fine. Well, technically, that's what it but you know what? Like your question's right though. Okay, like both those are right. Again, you can express probability in 4 different ways. It didn't specify how to do it. So either of them work. You could use it in words if you want. Now for question 2, Aiden had a good question. It doesn't say positive or negative O, it just says blood type O. So yeah, it's a good assumption here that we know that we have to add these up, right? So I have this many people O positive, this many people O negative. You add that up, you should get 396 over 850, which again, you can express,
Can we simplify it?
you can simplify it. Sure, why not?
Oh,
So yeah, if you simplify that, you get 198 over 425. Again, it does not specify, it does not tell you, it's not saying, you know, express as a decimal or anything like that. It's not telling you that. You can express it however you'd like. Then AB minus, there's only one of 850 people, so very rare blood type. So very small percent chance there. Now for question B, this is where it gets a little bit trickier. So they wanted to figure, they know this is a really rare blood type, right? Only 1 in 850 people have it. They want to know if they have a blood drive, there's 5,000 people coming, really successful event. How many people can they expect to have this AB positive blood? This one here.
1 out of 850.
So, sorry, I lied. AB plus. It was AB plus, not AB minus.
We just. Put 27 over 850 times 5,000.
Yeah, so there's 27 people. There's a 27 over 850 chance of this happening, of there's being someone who has AB positive blood. So we take the chance times it by the sample size. This is my chance. My sample size is 5,000. But these are my odds. This is my sample size. You put those together, you should end up with 159 people. So they know that of this 5,000, 159 of them are going to have AB positive blood. That's a guess they can do, right? Maybe there's only 100, maybe the 155 of them are there, but they have a good educated guess. Okay, so with that, I'm going to cut you guys loose, let you practice this stuff. We're going to be moving on to theoretical probability tomorrow, and that's where we're going to be playing some games. So for now, you can focus on your experimental probability. You can practice this out. After the break, we will be having a concept check on the last unit. Also, as a reminder, if you have your unit 3 exam style questions to submit that. So what to focus on. Let me check. Actually, I think you did. I didn't mark it yet because it wasn't due till today, but I'm pretty sure you did. But I'll double check in 5 seconds.
We are doing concept measure.
We are. I have Jasmine and I have Kim. Yeah, I have yours. And let me